This is part 2 of our lesson section 6.1. If two polygons are similar, then the ratio of the lengths of the corresponding sides is called the scale factor. So in that previous example we did in that last video, the common ratio of 5 to 3 was the scale factor of triangle TSR to triangle XYZ. Now this is important too, the order that you write these. Since we had the big number first, big to little, this triangle needs to be big to little. So keep that in mind when you're writing scale factors. In other texts, the scale factor might also be referred to as the similarity ratio. We're going to find the scale factor for these two shapes. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of the big polygon to the little polygon. So when we write our ratios, we should be writing big to little. So are they similar? Well, you need to check the corresponding angles. There's a match. There's a second match, third match, fourth match. So our corresponding angles are congruent. We just check that. And that's what you have to do if they're going to be similar. Now, the second thing you have to do is check the ratios of the sides. Are the corresponding sides proportional? Remember, that just means same ratio. So let's write our ratios big to little. So I'm going to start, because it says big to little, so I'm going to start on the big shape. And I'm going to start with the smallest side. 15 is the smallest side. So since that's the smallest side, it needs to go with the smallest side over here. It goes with 12. Now notice how both of these sides are on the right of the shape. If you just line up the right side with the right side, you're eventually going to make a mistake because this shape doesn't have to be a translation and an enlargement of this one. You could take this shape and flip it over or rotate it. So lining up littlest or smallest to smallest is the way to go. Now, bigger than 15 would be 20. So next biggest over here would be 16. 25 to 20. 24 to 30. You need to check these ratios and see if they're all the same. 15 to 12. 3 goes into both. 20 to 16, 4 goes into both. 25 to 20, 5 goes into both. 24 to 30. Did I do that right? 24 to 30? Think about that for a second. We're doing big to little, big to little, big to little, then I do little to big. I should have wrote 30 to 24. That's my mistake. So hopefully if you make a mistake like that, you can still catch it. Remember, we're doing big to little. 6 goes into both. So 5/4. Notice how every single ratio of corresponding sides is 5/4. Are the corresponding sides proportional? They are. They want you to write a similarity statement and find the scale factor. Well, what's the scale factor going to be? Scale factor is just that ratio that we found. So our scale factor is 5 to 4. And that should be a colon instead of an equal sign. We need a similarity statement. Big to little, remember. So name this any way you want. I'm going to name it X, W, Z, Y. That's going to be similar to this smaller one. Notice how X had the 2 arcs. H has 2 arcs. W is the right angle, so is J. So we're going this a ways. That's your similarity statement. In this diagram, the two triangles are similar. Find the value of x. So now we're not wondering if they're similar, they're telling you that they are. But what you need to do is find a missing side. So this similarity statement tells you 6 things. It tells you which angles are congruent. For example, angle D is congruent to angle M. Angle E is congruent to angle N. Angle F is congruent to angle P. Also, you know that this side length of 9 in between one arc and 2 arcs goes with the 12. 1 arc and 2 arcs. It's not left side to left side. That's a mistake if you do that. You can also look up here and see that segment DE goes with segment MN. That's really what you should be doing. Not left to left. Not bottom to bottom. Now, this 12, notice how that's in between arcs 1 and 3. Same thing here. So the 12 does go with the 16. And if you look at these better be the same because they're similar. Right? 9/12 is 3/4. So is 12/16. They're 3/4. So here's what this means. This ratio is 3 to 4. This ratio is 3 to 4. So take a guess what this ratio is going to be. It's going to be 3 to 4. That's your scale factor. So 3/4 needs to be the same thing as something over 12. How do you solve a proportion? Well, cross multiply. Here's the easy way to cross multiply. We're going to do 3 times 12, and that's 36. Take that 36 and just divide by 4. 36 divided by 4. Gives you 9. What did I do wrong here? Oh, why did I put a 12 there? It should be 20. It's 3 to 20, not 3 to 12. I am really killing it here. Again, I know, let's just use this mistake as a positive. If you thought that was 9, notice how that sure looks like a longer side than this one. Not that appearances are everything, but clearly that's the biggest side on this triangle, so shouldn't this be the biggest side on that triangle? Okay, 3 times 20 is 60. 60 divided by 4 is what you're looking for. It's 15.